So in this lesson, we're going to learn a few more characteristics about polynomial functions. We've already learned a couple about their finite differences, their domain and range. The characteristic we're going to look at now is called the end behavior of a function. And it describes, so I'll read the definition to you. The end behavior function describes the behavior, increasing or decreasing, of the function as the x values approach infinity or negative infinity. So that's a pretty technical definition, but really what the end behavior does is says what is happening to the y values as my x's become very big in the positive direction, and what's happening to the y value as my x's become very, very small in the negative direction. So it'll be much easier to explain when I have these two examples drawn. So we know how to sketch these, and I'll just quickly sketch them here. This is y equals x squared. Like up there, it's 4. It's symmetric, it's over there. And it looks like this, and like that. So this is the graph of f of x equals x squared. And I'm going to use this graph to describe I'm going to describe the end behaviors of this function, and it's going to help us to understand what that means. So the end behavior describes what's happening to the y values, what's happening to the values of the function as the x gets bigger and bigger and bigger and bigger and bigger. What's happening to the y values? As x gets bigger, our y values are also getting very, very big in the positive direction. So to describe the end behavior, we always say as x approaches positive infinity, f of x will be approaching also positive infinity, a very large positive number. And as x approaches negative infinity, we always look at x approaching positive infinity and also negative infinity. So as x approaches negative infinity, that means it's getting very big this way. Well, it's small actually. What's happening to my y values? They're getting big in the positive direction. So f of x is still approaching positive infinity. So that's my end behavior of x squared. Now we're going to look at the end behavior of x cubed. So first we're going to draw x cubed, and we kind of remember what it looks like, I hope. 1, 1, negative 1, negative 1. Oops, I'm going to put that negative 1 over there. Anyway, it looks like this. It kind of has a squiggle. Looks like that. And that's f of x. Okay, so again, to define the end behavior, we look at what's happening as x approaches positive infinity and what happens as x approaches negative infinity. What's happening to our function? So as x becomes very large in the x direction, what's happening to y? Well, it's also becoming very large in the positive direction, so we would say f of x is approaching positive infinity as well. And as x approaches negative infinity, that means x is going that way. What is happening to our y values? Clearly, they are getting very, very small, i.e. f of x is approaching negative infinity. So that's how we describe the end behavior.